Let's go over section 1.4. Let's solve the quadratic equation. The first technique is to factor. Let's factor this expression to solve for x. I need to isolate the quadratic term, so let's have it as x squared minus 7x plus 10 equals to 0. You want to set this equal to 0 before you try to factor. And now since this has three terms, let's use the diamond method. I have a 10 on top, a negative 7 on the bottom. The two numbers are 5 and 2, but they both have to be negative. So this factors as x minus 5, x minus 2 equals 0. Now what we're going to do is set x minus 5 equals to 0 or x minus 2 equals to 0. The reason is these two numbers multiply to give us a 0. So one of them has to be a 0, or it could be the other one being a 0. We'll add 5 to both sides, and x equals 5 for the first question. Now for the second part of the question, we'll add 2 to both sides, and we get x equals 2. In example 2, again, I want to set it equal to 0, but be careful. I like to keep this x squared positive. This x squared should be positive. So let's subtract the 2x instead to both sides. We get x squared minus 2x equals 15. And then we'll subtract 15 to both sides. X squared minus 2x minus 15 is equal to 0. Let's see if this thing factors with the diamond method. And the two numbers are 3 and 5. This must be a negative 5. So this factors as x plus 3 times x minus 5 equals to 0. Again, look at the factoring techniques. This has to be the diamond method because the leading coefficient is a 1. I can now say that x plus 3 could be 0 or x minus 5 could be 0. Let's subtract 3 to both sides. X equals negative 3 for the first part. And for the second part, we can add 5 to both sides. X equals 5. Now if I'm not sure, you could just plug these back into the original polynomial and you should get the left and the right side are equal. So you can check your work every time with these questions. In example 3, I want to again set it equal to 0. So let's subtract 49. X squared minus 49 equals 0. Now this has only two terms. I know this has to be the difference of squares. A minus b, a plus b is the correct formula for the difference of squares. So this factors as x minus 7, x plus 7 equals to 0. Again, we use the formula for the difference of squares. Since these two numbers multiply to give us a 0, x minus 7 is equal to 0, or it could be x plus 7 equals to 0. Let's add 7 to both sides, and here we'll subtract 7 to both sides. X equals a positive 7, or x equals a negative 7. Now that was the first technique, factoring. Now we're going to use a technique called extracting square roots. Step 1, isolate the square term. Step 2, take the square root of each side. Don't forget the positive and negative in front of each of the square roots. Simplify the square root, solve by isolating the variable. So let's try question 4. Now I want to find the exact solution, and then we'll use our calculator to simplify this to a decimal. I have x squared minus 50 equals 0. Let's add 50 to both sides. Again, I cannot factor this. There's no difference of squares that would work for this problem. So let's write it as x squared equals 50. Now, according to the directions, we could take the square root of both sides. Don't forget the plus or minus in front of the constant term. I have x equals plus or minus the square root of 50. Now, you can break down the square root of 50 as plus or minus 2 times 5 times 5. And remember, we're looking for groups of 2. So let's take that pair of 5 to the front. That is plus or minus first, and then the 5. Don't put it in front of the plus or minus. Remember, this is multiplication, so we need it in front of the radical. This is plus or minus 5 root 2. Now, if I enter this in my calculator, I should get this is plus or minus 7.071 approximately. So use your calculators and make sure you can also get the decimal form for it if the question requires you to. Practice with your calculator. Question 5. Let's again isolate the x squared term. That's nice. They already done it for us. So I can take the square root of both sides. Don't forget the plus or minus again. We have x on the left. The square root of x squared is just x, plus or minus. Now let's break down 28. That's 2 times 2 times 7. We'll look for the pair of 2's here. That's plus or minus 2 root 7. And that's our solution, plus or minus 2 root 7. Again, I want you to practice with a calculator. You can use your calculator and make sure you get about 5.292 on your calculator. Most of the time we enter it as an exact number like this, but sometimes we want a decimal form also. For example 6, let's again start by taking the square root of both sides. Don't forget the plus or minus. If you forget this, half your answer is missing. There's a positive and then there's a negative answer. We have x is equal to, well, that's the square root of a negative. I need to pull out the I and leave the 16 inside. But we know the square root of 16 is just 4, so this is plus or minus 4i. That is our solution to example 6. Now for question 7, I want to, again, isolate the x squared term, so let's subtract 32 to both sides. X squared equals negative 32. And now we could do the same process. We can take the square root of both sides. Don't forget the plus or minus. Now I want you to try these problems on your own also. So pause the video anytime you feel like it. Try the problem on your own as well. So I'm going to take out the I here and then leave the 32 inside. But we can break down 32 as 2 times 2 times 2 times 2. There should be 5 2's. Let's double check. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again, that's 32. So I know we did it right. We'll look for pairs of 2's. 2 times 2 here gives me 4. So x equals plus or minus 4i root 2. And that completes example 7. In example 8, some people might feel tempted to FOIL this out, then set it equal to 0, then factor it. That is a lot of work. I don't want to do that. That is going to be a lot of work. Instead, let's just take the square root of both sides, just like we did earlier. So we'll take the square root of 2x minus 7 squared and the square root of 25. We know the square root of 25 is 5. And on the left, the radical is going to cancel out with that squared term. That leaves us 2x minus 7. Now I could add 7 to both sides. That cancels out. I get 2x equals 12. And of course we could divide both sides by 2, get x equals 6. Of course we could check our work, plug it back into the original problem, and the left side should be equal to 25. Number 9 looks like an interesting problem, but it's very similar to 8. Again, I'll subtract 35 to both sides. We get 3x plus 4 squared equals 15 minus 35 is negative 20. And what do we do after this? Take the square root of both sides again. Once you isolate that square term, take the square root of both sides. Don't forget that plus or minus in the front. Now we can write this as 3x plus 4 equals plus or minus. There's a negative here. Let's pull out the I. And then we'll break down the square root of 20. We have 3x plus 4 equals plus or minus. Square root of 20 is 2 times 2 times 5. There's a pair of 2's. So I have 3x plus 4 equals plus or minus 2i root 5. Now we have to solve for x. Let's subtract the 4 to both sides. Now be careful, we're subtracting the 4 from this entire expression, so please put it in front of the plus or minus. We're not subtracting it from the square root of 5 or subtracting it from the whole thing, so it's best to put in the front so that people don't think it's inside that radical. Now I could divide both sides by 3, and here is our final answer. It is negative 4 plus or minus 2i root 5 all over 3. This is an ugly answer, but this is exactly what we're looking for question number 9. For question number 10, again, don't FOIL anything out, don't distribute. The first thing I want to do is subtract the 17. I want to isolate that squared term first. This term, I want to isolate this term so I could take the square root of both sides. We have 2 times 2x minus 3 squared equals negative 18. Then I can divide both sides by 2 to get rid of this. Don't distribute, that's going to make your life harder, and it's actually not allowed because the exponents have higher priority. But instead, it's okay to divide both sides by 2. So we'll rewrite this as 2x minus 3 squared equals negative 9. Now this looks like something we could do. Let's take the square root of both sides. Don't forget the plus or minus. This is 2x minus 3 equals plus or minus. I can pull out the I. And of course the square root of 9 is equal to 3. So we have 2x minus 3 equals plus or minus 3i. Let's add the 3 to both sides. I have 2x equals 3 plus or minus 3i. And finally, we can divide both sides by 2. X is equal to 3 plus or minus 3i over 2. Again, a lot of work, but it's not bad to do as long as you simplify by isolating the square term first. Let's learn how to do completing the square. The first step is to write the equation of the form x squared plus bx equal to c. Write it in this form first, then add b divided by 2 squared to both sides. After you do that, you need to factor the resulting equation on one side, and then you can do extracting the square root. Solve the resulting equation. Now let's try completing the square with this example. First, I need to get it into the x squared plus bx equal to the c form. So let's add 16 to both sides. X squared minus 6x equals 16. Now leave yourself some space. I need to leave myself some space here. So let's put these empty boxes, and I need to add b divided by 2 squared. So this is negative 6. Take that negative 6 divided by 2 and then square it. This gives me negative 3 squared, or 9. So that's the number I need to add to both sides. Again, we're taking the b, this is our b, dividing it by 2 and squaring it. So that gives us 9. I need to put a 9 here, and I have to put a 9 on the other side, because if you add 9 to the left, you better add 9 to the right. This gives me 25 on the right. On the left, I can actually factor this. This is negative 3 and negative 3. So this is x minus 3 squared, because there's two x minus 3's. We know how to do this. This is subtracting the square. So let's take the square root of both sides. Don't forget that plus or minus. Then we have x minus 3 equals plus or minus, this is a 5. Now don't split into two equations yet. Always wait till the end to do that. So I'm going to add 3 first to both sides. That gives me x equals 3 plus or minus 5. Now, since these are numbers that we can simplify, I want to write two separate equations. X equals 3 minus 5 is one, and then I'll write another one, x equals 3 plus 5. So we have two answers for this question. The first answer is a negative 2, and the second one's a positive 8. So wait till the end to split it into two separate equations with the plus or minus. I only do this if I know I can simplify it further. If there's a radical that shows up, just leave it alone, leave it with the plus or minus. If there's an imaginary number that shows up, leave it alone with the plus or minus. Example 2. Again, let's get it into this form, right? We want it to be equal to c, so let's subtract the 20. I have x squared plus 8x, leave myself some space again, equals negative 20, and again we want to leave ourselves some space. B over 2 squared is the number we need to find. That's going to be 8 divided by 2 squared. You get 4 squared. That's 16. That's our magical number 16. So let's put that to both sides. And again, look what happens. On the left, it factors as a perfect square again. This is x plus 4 times x plus 4, or x plus 4 squared. Negative 20 plus 16 is negative 4. So notice that every time this formula that we use to both sides allows us to factor the left side completely as a perfect square. Now we can take the square root of both sides. Don't forget that plus or minus. So we have x plus 4 equals plus or minus. Now what's the square root of negative 4? That is 2i. We could subtract the 4 to both sides. X equals negative 4 plus or minus 2i. And that's it. We can't simplify it further. There's an I that shows up, so we don't need to split it into two equations. Now, in question number 2 and 1, the middle term was even, and we were able to divide it by 2 pretty easily, add that to both sides. Now, if you look at question number 1, Again, we had the same situation. It was even. We divided by 2. That's a nice number. So it will be a little bit harder once it is odd. So let's try example 3 where it's odd. We'll add 5 to both sides just like before. X squared minus 5x plus something equals 5 plus another box. Now I'm going to take the middle number, that's negative b. I'm going to take the negative 5. So negative 5 divided by 2. Again, we're using b over 2 squared. Negative 5 divided by 2 squared is 25 divided by 4. We square the top, we square the bottom, we get 25 over 4. Unfortunately, you get a fraction. But that's okay, we can still use the fraction. Now here is the secret. I can factor this very quickly if you know the shortcut. Let's go back to number 1 and number 2 to look at what the shortcut is. Notice that this factors as negative 3 and negative 3. Look at the number in the middle, that's a negative 6. If I divide it by 2, I get that negative 3. Question number 2. It factors as x plus 4, x plus 4. Well, I know the 8 divided by 2 gives us 4. So that's the secret. This can be rewritten as x. Now this number right here, this negative 5, let's divide that by 2. I could put it in here. So this actually factors as x minus 5 over 2 times x minus 5 over 2, or x minus 5 over 2 squared. That's from this formula. It always works. So use the middle number divided by 2, and that's what you get here. That's what this will give you every time. So I don't even have to think about factoring it. This thing is always b cut in half. Now on the right side, I have to get common denominators. So let's multiply the top and bottom of this one by 4. Let's multiply the top and bottom by 4. This becomes a 20 over 4. So we have x minus 5 over 2 squared equals 20 over 4 plus 25 over 4 is 45 over 4. Let's take the square root of both sides. Don't forget the plus or minus. And we have x minus 5 over 2 equals plus or minus. The square root of 45 is the same here on the top. On the bottom, I'm going to write that as the square root of 4. So we use our quotient rule for this to simplify this as the square root of 45 over the square root of 4. Now I can write this as x minus 5 over 2 equals plus or minus. Now 45, that's 9 times 5. So the square root of 9 is 3. So this is 3 root 5. Again, you could use the factor tree to simplify it as 3 times 3 times 5. So this simplifies to 3 root 5. The square root of 4 is 2. Now I can add 5 over 2 to both sides. And I have x equals 5 over 2 plus or minus 3 root 5 over 2. It's still not done. We have to get the numerators added up. So this is x equals 5 plus or minus 3 root 5 all over 2. Now we're finally done. So this is a lot more difficult, all because that middle term was odd. Would I use this method for a regular homework question? Probably not. I would only use it if this middle term was even, then I would use completing the square. But since it's odd, it's a lot more difficult. I would rather use something else. And we're going to learn what that something else is. That something else is the quadratic formula. But we'll do that after we try another example. Let's add 18 to both sides. Leave myself some space. Now, b is 7. We'll divide that by 2 and then square it. That is 49 over 4. So let's add 49 over 4 to both sides. Now, don't think about it. Just factor the left side. It's just x. Whatever this is b, which is 7. Cut that in half. And then put a squared out there. That's all you have to do. You don't have to think about factoring it. This is just a shortcut. So divide that by 2, bring it down here. This, let's write this as 18 over 1 plus 49 over 4. Let's multiply the top and bottom by 4. 1 times 4 is 4. 18 times 4, that's 72. This is equivalent to x plus 7 over 2 squared equals 121 divided by 4. Because 72 plus 49 is 121. Now let's take the square root of both sides. Don't forget that plus or minus in the front of the constant term. I have x plus 7 over 2 equals plus or minus the square root of 121 over the square root of 4. Now, on the right side, what is the square root of 121? That's 11. What's the square root of 4? That's 2. So now I can simplify this by subtracting the 7 over 2 to both sides. This cancels out. X equals negative 7 over 2 plus 11 over 2. That can be simplified, so let's add them up as negative 7. I forgot the plus or minus symbol. Don't forget that. So that's a plus or minus 11 over 2. And now I could simplify this as negative 7 minus 11 over 2, or x equals negative 7 plus 11 over 2. This simplifies as, that looks like a negative 18 over 2, so that's negative 9. Now this one simplifies as 4 over 2, so that's actually just 2. So quite a lot of work, but we were able to get our 2 solutions.